Our turn. This video demonstrates how to transpose sets by working 3 sample problems. For this video, I'll use method 1 to solve the problems and method 2 to check my answers. You may feel free to use whichever method you prefer. Method 1 uses addition and subtraction of numbers, but deals with mod 12, and method 2 more closely resembles the transposition of tonal melodies. Transpose the starting pitch, then create the same interval pattern of the original. The first step in either method is to write the pitch class numbers of the notes. In number 1, G flat is 6, A flat is 8, and C is 0, and we're done with step 1. For a review of how to label pitch class numbers, refer back to that section of the book. In this problem, we need to transpose 2 half steps up, or add 2 to each number. 6 plus 2 is 8, 8 plus 2 is 10, and 0 plus 2 is 2. We've completed the second step. The final step is to write these numbers as pitches on the staff. Pitch class 8 is A flat or G sharp, 10 is B flat or A sharp, and 2 is D. Remember that spelling doesn't matter when dealing with pitch class. Now we're finished with number 1. Let's check using method 2. The original starting pitch was G flat, which needs to be transposed up 2 half steps or a whole step to A flat, our new starting pitch. We build up from that pitch using the same sequence of intervals as the original, which has a major second from G flat to A flat, which matches our answer from A flat to B flat, followed by a major third from A flat to C, which also matches our answer B flat to D. Moving to number 2, the pitch class numbers are 4 for E, 5 for F, 7 for G, and 10 for B flat, and we're done with step 1. We're asked to transpose up 9 half steps. Remember from the video on transposing sets that there's a shortcut for transposing by large numbers. Treat them as smaller intervals moving down. 9 half steps is the same as 3 half steps down because the 2 intervals are inversions of each other. You can find the inversion by figuring out what number will add up to 12 half steps, the number in an octave. In this case, 9 plus 3 is 12. So let's subtract 3 instead of adding 9. 4 minus 3 is 1, 5 minus 3 is 2, 7 minus 3 is 4, and 10 minus 3 is 7. We've now completed step 2. The final step is to put those pitch classes on the staff. Pitch class 1 is C sharp or D flat, 2 is D, 4 is E, and 7 is G. Notice that I chose arbitrarily to put these pitches in the middle C octave, which makes the transposed set appear lower than the original. It doesn't matter what register you choose in set theory, our answer is still T9 no matter what octave we choose. Now we're finished with problem 2. Using method 2 to check our answer, we look at the starting pitch E and transpose up 9 half steps, or down 3, a major sixth up or a minor third down, which we have in our starting pitch C sharp. The interval pattern of the original is a minor second, which matches our first interval, followed by a major second, which matches, and then a minor third, which also ends our answer. Let's label the pitch class numbers for problem 3. D sharp is 3, F sharp is 6, G sharp is 8, A is 9, and B is 11 to complete the first step. For step 2, we need to transpose up 4 half steps, or add 4 to every number. 3 plus 4 is 7, 6 plus 4 is 10, 8 plus 4 is 0 in mod 12, 9 plus 4 is 1, and 11 plus 4 is 3. Don't forget, when adding and subtracting in mod 12, it's helpful to think of the clock face. Now we're done with step 2. All that's left is to fill in the notes on the staff. Pitch class 7 is G, 10 is B flat or A sharp, 0 is C, 1 is C sharp or D flat, and 3 is D sharp or E flat. We've completed the final step. Returning to method 2 to double check, we see that the starting pitch D sharp needs to move up 4 half steps or a major third. A true major third from D sharp would be F double sharp, so let's change the spelling in our minds to E flat. A major third from E flat is G, our new starting pitch. The intervals of the original are a minor third, which we recreated with G to B flat, then a major second, which we have from B flat to C, a half step, which matches our C to D flat, then a whole step, which we have between D flat and E flat. That's how we found the solutions to these sample problems on transposing sets. Now try the your turn problems on this topic, and then use the next video to check your answers.